Okay, so for this video, we are going to be talking about frequency tables. Shine some light on that. Okay, so frequency tables are tables that report the number of observations falling into each category of the variable. These are going to be really simple, straightforward charts, and I am 100% sure that you have seen them before. The categories of the frequency distribution must be stated in a way that permits each case to be counted in one and only one category. And this also sort of blends in with our question design and the way that we set up our variable responses, the type of answers that people can give us, because we want to make sure that we don't have any overlap. And so for ordinal and interval ratio variables, this table should be arranged so that the values of the variable are in order, right? So if I ask, again, like the number of, the highest education you have received, when I put this in my chart, the highest education you've earned, it shouldn't say, PhD, GED, master's, bachelor's, whatever, right? It should be in order. But again, when we look at things that are nominal variables like your political party affiliation, there's not really a ranking system there, so it doesn't really matter exactly how we put in our nominal variables into a frequency table. But it absolutely matters when it comes to ordinal and interval ratio variables. So let's look at an example here. So if I tell you, these are the death penalty statutes as of 1994 or 1995, and that tell us the minimum age for death penalty in all of these states. And so if I want you to make me a frequency table that tells me how many states is the minimum age 14, how many states is the minimum age 15, give me a frequency table of minimum age and number of states. So if we do that, we are going to do a tally, We're going to count. There's one state that has a minimum of 14, So that happens once. 15 once, 16 9 times, 17 4 times, and 18 12 times, which gives us a total of 27 states, So going back, we see 14 1, 15 1, 1, 16 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 is 16, 17. Why are we going the wrong way? 1, 2, 3, 4, only 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, So count them just like that, And then this tells us, when we add up all of the numbers, it should give us the same total number as the number of states that were listed, which it does. So this is our frequency distribution, and then we're going to take this and put it in a chart that looks just like this, We're just going to get rid of the tally part, and then we're going to have, our frequency distribution here. Put this in a chart, and this is a frequency distribution chart. Super easy, and so we are going to be refreshing our lesson here on proportions and percentages, because oftentimes in our frequency charts, we will have the percent and the cumulative percent. So again, remember our proportion is a relative frequency obtained by dividing the frequency of each category by the total number of cases. And when we talk about relative frequencies, it is the fraction of times an answer occurs, Which pretty much means how often something happens divided by all outcomes, And so when we do this, this is going to help us see, what this means. So this, go back, this data set is pretty straightforward, but it's going to help us see what percentage of states, have a 14 age cutoff for the death penalty, or 15, or 16, or 17, or 18. So we are going to start by finding the proportion, which makes sense because you have to find the proportion before you can find the percentage. So to find the proportion, my frequency is 1, and I'm going to divide that by my n, my total number of cases, which gives me 0.037. When I multiply that by 100, that gives me the percentage of 3.7. And we do that the same thing for 15, same answer, just copy and paste. 16, we're going to do 9 divided by 27, which gives us 0.333. Multiply that by 100, that gives us 33.3%. 17, minimum age, we're going to take 4, divide it by 27, our total number of cases, that gives us 0.148. Multiply it by 100, it gives us 14.8%. And finally, age 18, our frequency is 12. We're going to divide that by 27. That's going to give us 0.44444444. We multiply that by 100, that gives us 44.4%. So when we add all of these up, it gives us to 100%, which, right, because that's all of our cases. So every time you add these up, it should equal 100. Every once in a while, because of the rounding, when we add them up, it might equal 99.9. If you get that answer, just go back and double check. But if it is anything other than 99.9 or 100, you've probably calculated something wrong, because all of these percentages, right, make up the whole. This tells us this is 3.7%, this is 3.3, this is 3.7%, that's 33.3% of this entire whole, right? So all of these should always add up to 100, and your proportions should always add up to 1. Right? Again, this makes sense because we are looking at the fraction of the whole. And so the whole should be 1 or 100, depending if it's proportion or percentage. And our fractions should add up to 1 or 100. And so oftentimes you will see in frequency charts that there is a cumulative percent. And so this is a distribution showing the percentage at or below each category of the variable. And again, we're going to use these for ordinal and interval ratio variables, not nominal variables, because it's difficult to assess this information with nominal variables. It doesn't really make the same kind of sense. So if I did a survey, right, of, right, wow, that doesn't add up at all, does it? Hold on, what have I done? Okay, so I surveyed 100 people. Top 5 answers are on the board. Just kidding. So the number of kids, right, is how many people, right? How many people have this many kids? Then we have the frequency, right? How many people said I have no kids? How many people said I have 1 kid, 2, 3, more than 4? And then we have percent, right? So because I made these numbers 100, it's super easy to figure this out, right? So 55% of people have 0 children, 25% of people have 1 child, 10% have 2, 5% have 3, and 5% have 4 or more. And so our cumulative percent over here is going to continuously add the next one to move up, right? So 55, right? Cumulative percent is 55. That's our bottom one. So to find the next step, I'm going to add this 25% to my 55%, and that's going to tell me 80% of people either have 0 or 1 kid. Next, right, we're going to add our 10% to 80, giving us 90 here for the cumulative percent. And so 90% of people that I studied have 2 or less children. All right, moving up. 3%, number of kids, 3, 5% of people, add that to their previous one with the 2 children, and now we have 95% of our sample have children, have 3 or less children, right? And then that also tells me here, right, that maybe if I go back up here to 2 and I'm looking at 90% cumulative, that means 90% of my sample has 2 children or less, but then that also tells me that 10% of my sample has more than 2 children, right? So this cumulative percent can sort of help us see where the breakdown is, right? That where, like, how these things sort of relate to one another. Going back just a second, when we were talking about frequency tables and how it's important to have it so that our right, none of these categories can overlap. So I might have asked my survey and said, okay, how many kids do you have? I gave them 0, 1, 2, 3, 4, plus 4, 5 plus, whatever. But if that's my thing and I am trying to sort of condense that into a frequency table, I have to be conscientious to say, okay, I can't have frequency number of kids 0 to 1 on one thing, then the next one 1 to 2, and then the next thing 4 to 5, right? We have to make sure that there is no overlap here, and that it all sort of makes sense in the way that we have organized it. So that is the cumulative percent for frequency distribution tables. Pretty straightforward, right? But it just helps us sort of break down and visualize this data in a way that really helps us understand the relationship between the different values of the variable. Now, I am sure that most of you, especially if you are in crim or a criminology concentration, have heard about rates, right? We use rates a lot in different ways, right? And it's a number obtained by dividing the number of actual occurrences in a given time period by the number of possible occurrences. But we have to be careful when we do this, right? Because right, it's not always an accurate statistic. So if we take this example, if we take the marriage rate in 1990, that would be that we would take the number of marriages in 1990, and then we would divide that by the total population in 1990. But if we look at that forward, right, we see that there were 2.448 million marriages in the US and 250 million Americans, which tells us that our marriage rate was 0.0098. However, there is a problem with this computation. Can anybody figure out what that problem might be? I'll give you a second. I feel like I'm recording a kids show and like they're going to add in like the children screaming in the background, like there it is, like Blue's Clues or Dora Explorer. Okay, so the problem with this rate computation, right, is that it is not an accurate statistic because it's not the number of possible occurrences, right? Because what we're doing is we're taking the number of marriages divided by the number of Americans, but guess what? It takes 2 Americans to get married, right? You cannot marry yourself. Therefore, right, this is not really a accurate statistic, right? Because we would have to do something else to this number, right, to determine right, the number of marriages. Like, how would we calculate this? Right, because there are 250 million Americans. However, right, 2 of them have to get married. But even if we divided that by 2, that still might not give us the most accurate statistic, right? Because right, maybe we're counting different things or different people, right? We don't really know exactly how many people were married in the US, right, compared to the population. What about people who got married more than once in that year? What about, right, divorces? What about all of this other stuff? Right. So rates aren't always the most accurate statistic. When we are doing data analysis, right, we will often use anything other than a rate, right? Because a rate is not the same thing as our right, as our proportions and our percentages, because here we're estimating, right? We don't know exactly how many people in this survey, right? How many people in America actually got married. We know the number of marriages and the number of Americans, but that doesn't give us everything we need to know. So we are not going to be using rates, right? We are using the data that we have, right? We're going to take the proportion and the percentage from that data, and we are not going to worry about rates. So that is frequency tables, proportions, and percentages, as well as cumulative percents, and why we don't use rates. And so that is going to be it for this video. Coming up next, we are going to talk about measures of central tendency, which are our mean, median, and mode.